Have you ever wondered what would happen if the entire world suddenly lost power? No lights, no internet, no phones? It sounds like a scene from a disaster movie. But some scientists are warning that this could become our reality, and sooner than we think. The culprit? A massive solar storm brewing 93 million miles away. Today, we read diving deep into the science behind these cosmic tempests and why experts are on high alert for a potential global blackout. So, what exactly is a solar storm? Imagine our sun, a giant ball of fiery plasma, occasionally having massive eruptions. These are called solar flares and coronal mass ejections, or CMEs. They'd blast enormous amounts of energy and magnetized particles out into space. Most of the time, these cosmic blasts miss Earth entirely or are harmlessly deflected by our planet's magnetic field, creating the beautiful auroras, the northern and southern lights. But what happens when a really big one heads directly for us? This isn't just science fiction. It's happened before. The most famous event is the Carrington event of 1859. A colossal solar storm slammed into Earth, and the results were dramatic. Telegraph systems, the high-tech of the day, went haywire. Operators received electric shocks, telegraph paper caught fire, and some systems even continued to work after being disconnected from their power sources, running solely on the electrical charge in the atmosphere. Now imagine a storm of that magnitude hitting us today. Our world is infinitely more dependent on electricity and technology than it was in 1859. Consequences would be catastrophic. Our modern power grids are the backbone of civilization. They are vast interconnected networks, and that interconnectedness is their biggest vulnerability. A powerful CME can induce massive electrical currents in long conductors, like power lines. These geomagnetically induced currents, or GICs, can flow into transformers at substations, causing them to overheat, melt, and even explode. If enough transformers are damaged simultaneously across a wide area, it could trigger a cascading failure, bringing down an entire continental power grid. And this isn't a small, temporary problem. Large, custom-built transformers are the heart of our electrical grid. They can weigh hundreds of tons, cost millions of dollars, and take months, if not years, to build and install. We don't just have a stockpile of these sitting in a warehouse. A widespread event could destroy hundreds of them at once. The manufacturing and logistical challenge of replacing them would be immense. Experts estimate that a severe solar storm could leave large parts of the world without power for months, or even years. Let's really think about what that means. No electricity means no running water, as the pumps wouldn't work. No refrigeration for food and medicine. No gasoline pumps, so transportation would grind to a halt. Hospitals would have to rely on backup generators, but how long would their fuel last? Communication systems would collapse. No internet, no cell phones, no television. Banking and financial systems would freeze. In a matter of days, our complex, modern society would be thrown back to a pre-industrial age. But without the skills and local infrastructure that people had back then, it's a truly frightening scenario. So why the sudden urgency? Scientists who study the sun have noticed that it goes through an approximately 11-year cycle of activity, from a quiet solar minimum to a turbulent solar maximum. We are currently heading towards the peak of solar cycle 25, which is predicted to be more active and arrive earlier than initially forecasted. We're already seeing an increase in solar flares and CMEs. In fact, we've had some close calls in recent years. In July 2012, a Carrington-class CME tore through Earth's orbit, but it missed us by about 9 days. We were lucky. But luck isn't a strategy. The scientific community is taking this threat very seriously. Organizations like NASA and NOAA have a fleet of satellites, like the Solar Dynamics Observatory and the Parker Solar Probe, constantly monitoring the sun. These provide us with an early warning system. When a significant CME is detected heading our way, we could have anywhere from a few hours to a couple of days of notice. This isn't a lot of time, but it's crucial. With a warning, power grid operators could take protective measures. They could strategically disconnect parts of the grid, reroute power, and put sensitive transformers offline to minimize the damage. This might mean planned, controlled blackouts, but that's far better than an uncontrolled, catastrophic collapse that could last for years. This early warning system is our best defense, but it's still a work in progress. We need more investment in space weather prediction to improve the accuracy and lead time of these warnings. Beyond just prediction, there's also a push to harden our infrastructure. This involves upgrading our power grids with new technology that can better withstand geomagnetically induced currents. Things like installing blocking devices to prevent currents from entering transformers, or developing more resilient transformer designs. However, these upgrades are incredibly expensive, and implementing them across an entire country's ZES grid is a monumental task that will take decades. It's a race against time. The sun has been relatively calm for the last few decades, which has perhaps led to a sense of complacency. But history and science tell us that the big one is not a matter of if, but when. We've built a fragile, technological civilization that is deeply vulnerable to the whims of our own star. So what can we do? As individuals, being prepared for any kind of extended power outage is always a good idea. Having a basic emergency kit with water, non-perishable food, a first aid kit, and a battery-powered radio is a start. But the real solution lies in collective action. We need to support and demand that our governments and utility companies invest seriously in both space weather prediction and grid modernization. Public awareness is the first step. The more people understand the very real threat posed by a severe solar storm, the more political will there will be to take the necessary steps to protect our future. This isn't about fear-mongering, it's about being realistic and proactive. We've harnessed the power of the atom and walked on the moon, but we remain at the mercy of the star that gives us life. Understanding this vulnerability is the key to overcoming it. We need to treat the threat of a major solar storm with the same seriousness as we treat other major natural disasters. The storm is coming. The question is, will we be ready when it hits? Thanks for watching. If you found this video informative, please give it a thumbs up and share it to help raise awareness. And don't forget to subscribe and hit the notification bell so you don't miss our next deep dive into the fascinating and sometimes terrifying world of science. Stay curious, stay safe,